In this online lecture, we'll be discussing chemical bonding. So we're going to talk about what it is, the two main types, and how you can predict, if you know what two atoms are going to bond, which of the two main types of bonding you're going to get. So chemical bonding is when two atoms stick together. And there are two main ways in which two atoms can kind of stick to each other. The first way is called covalent. So that would be covalent bonding. And the second way is called ionic bonding. Both of these types of bonding have to do with valence electrons. So both types of bonding happen when atoms' valence electrons interact with each other. But what happens with those valence electrons is different. In covalent bonding, the two atoms will share valence electrons. And in ionic bonding, the two atoms will transfer valence electrons. Now, before we go any further, let's just recall that we already learned how to tell how many valence electrons an atom has by looking very quickly at the periodic table. And we also learned this rule that all atoms want to try to have a full valence shell. They want to try to have 8 valence electrons. And sometimes it's easier for them to do that by gaining electrons, and sometimes it's easier for them to do that by losing electrons. So let's take a peek here at an example when sharing might be the best way for an atom to get 8 valence electrons. Let's say we had a carbon atom. And carbon atoms have 8 valence electrons. And I'm going to draw them as dots. We're going to learn a little bit more about how this type of drawing works later. But for now, we're just going to say each one of these dots is a valence electron. You'll notice carbon has 4 of these valence electrons. But it doesn't want 4. 4 is only half as many as it can have. It wants 8. That would be a full valence shell. And let's say that this carbon atom encounters a fluorine atom. Fluorine has 7 valence electrons, which I will also draw with little dots. 7. So fluorine is very, very close to having a full shell of valence electrons. It only needs one more electron and it will have a full shell of 8. Right now it has 7 as an atom. If it had one more, it would have 8. Carbon, with its 4 valence electrons, would need 4 more electrons for it to have a full shell of 8. So an interesting thing happens when you mix carbon atoms and fluorine atoms. The fluorine atoms will kind of surround this carbon atom, 4 of them, and each one of the fluorine atoms has 7 valence electrons. And the fluorine atoms are going to end up sharing one of their valence electrons with the carbon atom. And the carbon atom is going to share one of its valence electrons with each fluorine atom. And so what you get looks kind of like this. The carbon will share this electron with this fluorine atom, and it will share its lone valence electron with the carbon atom. And then the same thing will happen over here. They share their lone valence electrons, and then over here and over here. Now, let's think about what's happened here. By sharing these valence electrons, let's count how many valence electrons each atom has now. This fluorine atom has 1, 2, 3, 4, 5, 6, 7, 8, because it's got access to this valence electron from carbon now. So it has 8 valence electrons. This fluorine has 1, 2, 3, 4, 5, 6, 7, 8. Now that it has access to that carbon valence electron. This one has 8, and this one has 8. So all of the fluorine atoms now have the 8 valence electrons that they wanted. That gives them full valence shells, and it makes them happy. Very stable at this point. Look at the carbon. The carbon has its 4 original valence electrons, but then it's got these 4 valence electrons, one from each one of the fluorines that it didn't have before, that it has access to now because the carbon and the fluorines are sharing their valence electrons. And so now the carbon also has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons in its outermost shell. So by sharing their unpaired valence electrons, these atoms have all achieved a state where they have a full valence shell. They all have 8 valence electrons. If a carbon atom is sharing its valence electrons with a fluorine atom, well, then those two atoms can't get very far apart, because if two atoms are across the room from each other, they can't really share their electrons, can they? And so through sharing their electrons, these two atoms kind of get hooked together, and that's what we call the covalent chemical bond. And there are 4 covalent chemical bonds in this little example that I just gave to you. So covalent chemical bonds are sharing. Now let's notice something else about these. Carbon is a nonmetal and fluorine is a nonmetal. And so there might be a little bit of a pattern there, and we're going to come back to that in just a second. Okay, so now let's talk about ionic bonding. Ionic bonding is when there's a transfer of valence electrons. So we're going to look at sodium. Sodium, metal. It has 1 valence electron. And then we're going to look at chlorine. Chlorine, like fluorine, is a halogen. It's in group 17, which means that it has 7 valence electrons. Now, we've learned in a previous lecture that all of those metals on the left-hand side of the periodic table, they all want to lose valence electrons, whereas the nonmetals on the right-hand side of the periodic table all want to gain valence electrons. So that's exactly what happens. This sodium is going to take this valence electron and it's going to give it to chlorine. And chlorine is going to take that valence electron because sodium wants to lose its valence electron and sodium wants to gain a valence electron. And so what you get then is you get sodium becomes a positive ion. It's happy even though we don't realize it, because when it loses this one lone valence electron in its highest energy level, the energy level below it is actually full of valence electrons, so that makes it happy. And then chlorine, with its extra valence electron, has 8 now. One of them was from sodium, so let's go ahead and draw that in black so that we remember where it came from. It's got 8 valence electrons now, and it becomes a negative ion. And you guys have been learning for a very long time, opposites attract. These two ions have opposite charges, so they're attracted to each other. And that attraction is going to hold them together. It's going to hold the sodium ion. It's going to be attracted to and stuck to this chlorine ion, and they're going to stick together. They're going to stick to each other. And that transfer, which causes these atoms to become ions, and then it causes the oppositely charged ions to stick together, right? That attraction that sticks the opposite ions together is called an ionic bond, an ionic chemical bond. So those are the two main types. You've got covalent chemical bonding, that's one main type, and remember that's when the atoms are sharing their valence electrons. And then you have ionic chemical bonding, and that's when the atoms transfer their valence electrons and become ions, and that makes them stick together. So that's what the two main types of chemical bonding are. That's how they work. Covalent is sharing, and ionic is transfer, and then they turn into ions. How can we tell? How can we tell when, if I just give you 2 elements, how could you tell if they would bond covalently or if they would bond ionically? Well, the pattern is in what type of element they are. So with the covalent, we had a nonmetal, fluorine, right? All these fluorines are nonmetals, and we had a nonmetal carbon. But down here, with the ionic bonding, we still had a nonmetal, which in this example is the chlorine. But down here, we also have a metal, which in this example is sodium. So this pattern holds pretty well, and so we can kind of make a rule out of it. And like with any rule, there are some exceptions, but it works well enough for us to learn and to remember. And so the pattern is, if it's a metal element with a non-metal element, then you're going to have covalent bonding. And if you have a I just did that completely backwards. Here, let me erase that really quickly. We'll erase it the easy way. Jeez. Even teachers can make mistakes sometimes. So, okay, so metal with a nonmetal is ionic bonding. Metal with a nonmetal is ionic bonding. Right? Metal with a nonmetal, that's ionic bonding. And then when you have a nonmetal with a nonmetal, that is covalent. Covalent. And so our example up here, we have the nonmetal fluorine with the nonmetal carbon, and that is our example of nonmetal being covalent. So if in the future in the course, or whenever you encounter two pairs of elements, you just have to ask yourself, if you're trying to figure out how they're going to bond, are these things metals or nonmetals? If you've got two nonmetals, like let's say I said hydrogen and oxygen. Well, hydrogen is a nonmetal, oxygen is a nonmetal. So that would be a covalent bond that forms between those two. If I said calcium and sulfur, calcium's a metal, sulfur's a nonmetal, so you would predict that when those two bond, they would bond ionically. And that's really all there is to it. You just have to kind of figure out what type of an element is, and then you compare it to this pattern right here, and you can predict if it's ionic or covalent. As always, if you have any questions, you can ask in class. Thank you for watching.